Hello guys, welcome to my class. Today we are going to analyze and design a circular overhead water tank for concrete structure. Okay, you can see in the picture. We are going to design the structure and analyze it. At first, open STAAD Pro. Click on New Project. Click on Space. Length unit meter and force unit kilonewton. You can choose the name and location. Then click on Next. Click on Add Beam. Then Finish. Now switch off the grid. Go to Geometry and select Run Structure Reset. Model type frame model, and we are going to select reverse cylindrical frame. Now drag into the axis. Now length is 10 meter for me, radius 5 meter. Okay, you can change it to 6 meter. Now base 5 and going to give it 3 and change it to first one is 3, second one is 3, and third one is 4. Okay, now base 18, then apply it, and this is your structure. Transfer it to STAAD Pro. Yes. Okay, now delete this beam. We don't need that beams. Delete. Press delete from your keyboard and enter. Now you have to create the base of the tank and the top of the tank. In the top we are going to create a tomb. Okay, for that select the top portion, go to View, select object only. Now we have to create a beam in the middle. Okay, now these are middle beam, and select this beam. Click on right option on the beam. Click on Insert Node and select at midpoint, and a node is created in the midpoint. Now select the node, copy the node from your keyboard, Ctrl C, and paste the node, Ctrl V, in the Y direction. We are going to uplift the node 0.5. Okay, now the node which I have created first, delete this. Press delete from your keyboard and enter. Now you can go to the front view. You can see the node is in the upper portion. Now select, go to Add Beam and join these node to all nodes by Add Beam. You can go to circular repeat, but I am going to use it manually. In the next video I will show you how to use circular repeat. Okay, now our portion is complete. Go to display whole structure. Now you have to go to the bottom one, select the bottom one, go to View, select Date Object only. Now we have to create two nodes. For this span is longer. Okay, now we have to merge it to 2 to 4 beams. For that, go to select, merge, not merge, you have to intersect that. Go to intersect. Okay, and there is for 2 beams we are created 4 beams. Now go to whole structure and we have to create some plates. Okay, now select the side portion. Okay, now see, I have selected the side portion and don't need the base beams, so deselect them. Don't forget to press Ctrl from your keyboard. And see, these are the rectangle shape and these closed. for plate we have to select closed figure. Okay, so for creating plate you can go to generate surface meshing, but you have to do all the plates, it take more time. In shortcut you can go to fill floor grid with plates. Now 18 plates are created, and in a second the plates are created. Now again go for the upper portion, now select the upper one. You can see this is the closed one, triangle but closed one. Now go to fill floor grid with plates. Now upper portion is complete, and we have to create the down portion. Okay, now select the down portion, go to view selected object only, and we have to create the plate by generate surface meshing. Now click the node, now change division 1 to 10 to 1 for the all of the plates. Okay, now go click on OK. Now our bottom plate is complete. You can go to 3D render view, you can check this. Now you have to give the support for the structure. Go to support page, click on create, select the fixed support, add it. Now select the support, select the nodes, okay. Now click on assign effective nodes, assign yes. Now I have to give the property, go to define for rectangle. For columns we are going to give 400 mm by 400 mm, then add it, and for beam 400 mm by 300 mm, add it, close it. And for slab going to thickness, plate element thickness will be 0.2 as in 200 mm, add it. Now make sure you have select the concrete material or the concrete. Now select the column property, and we have to select the column ones. For then go to select beam parallel to y-axis, because column are in the y-axis. Click on assign to selected beams, assign yes, and have to select the beam property. Go to front view and select the beams by beam cursor. Don't forget to press Ctrl from your keyboard. Sorry. Now our all beams are selected. Now click on assign to selected beams, assign yes, and now for the plate thickness. Now select plates by plate cursor, click on assign to selected plates, assign yes. Now we have to give the loads. You can check the 3D render view. Okay. Now go to load page, click on load case detail, click on add, select load case 1. Now select load case 1, add it, select the self weight, add the plate loads, pressure on full plate, give the pressure 60 kN in the global Y direction. Now add it. Now for water pressure we are going to select hydrostatic, and we have to select the plates. Now for that go to select plates, and we have to select the plates by plate cursor, go to front view. Now select the side plates. Okay, now side plates are selected, done. Give the pressure 40 to 5, interpolation along y-axis, and direction of pressure is local Z. Now add it, close it. and you're gonna see the pressure is toward the wall. Now select the self weight, goes to the whole structure. Now I'm going to select assign to view for whole structure, yes, and the pressure on full plate on the base of the tank. Okay, now click on assign to selected plates, assign, yes, and you can see the pressure is acting on the plates. And for the upper portion, go to load case 1, click on add, click on plate loads, click on pressure on full plate. For portion the load is less, so we are going to give -2 in the global y-axis, add, close. Now select the pressure, select the upper plate, and click on assign to selected plates, assign, yes. Now I have to analyze it, go to comment and analyze, personalize, okay, analyze, run analyze. You can see there is no error, no warning, and no note. So our modeling part is complete, and we are going to design it. Okay, for that go to design, concrete design, select your code. I'm going to select BS807, but you know how to use IS456 and BS808110, okay, because in that previous session I showed you. Now go to select parameters, select the parameters. I'm going to select clear, FC and FY min, and okay. Now select define the parameters. Cover will be 0.03 as in 30 mm, add compressive strength 20,000, add FI min 415,000, add, close. Now it goes to the whole structure. Go to assign to view, select the parameters, go to assign to view, yes, save the parameters, go to assign to view. Now go to comments. Now select the design slab. You can design being the column, okay. If you can't, then let me know, comment on my video and I will get back to you soon. Now design the slab element, add, close. Now select design element and select the plates by plate cursor, click on assign to selected plates, assign, yes. Okay, now I'm going to analyze it, comment, analyze, personalize, open to okay, analyze, run analyze, save. Okay, good news, there is no error, no warning and no notes. So our design part is also okay. Go to view output file, done. Now go to concrete design and you can see the top reinforcement, bottom reinforcement, okay, the spacing on top, moment, top positive moment, bottom negative moment, top positive moment, bottom negative moment, okay. For the all are the slab, you can see the all the slabs reinforcement design is here, okay. Now go to post processing, click on OK. You can check the reaction for the columns, okay. Go to beam, you can check the bending moment, how it works on the beams as usual as columns, okay. You can go to the graphs, you can see the graph of the member for column, for beam, okay. And go to the stress, Okay, you can see the axial force. Okay, you can see the shear in Y, shear in Z. You can see the deflection. Go to the animation, click on deflection, apply. Okay, you can see in the bottom portion the deflection is maximum for the top and the bottom also. Okay, and you can also go to the reports for output and select which one you want to output, then click on OK. Now this is your report for analyze and design a wide water tank, circular water tank. Now that's it. That's how you're gonna analyze and design overhead circular water tank. And this is the type 1. We are going to design another type of circular water tank. So keep subscribing on my channel for watching more exciting video. So thank you for watching my video.